today we will be learning a lesson on optimization. It has something to do with our polynomial lessons we've been doing, but also will incorporate other functions beyond polynomials that will be helpful to you in calculus. On the first page of your notes, I'll let you look at these if you get confused. I will explain them as I go. But when you go back to do your homework, you might want to read the steps, if that's helpful to you. Turn the page and let's start with the example. A farmer has 2,500 feet of fencing to enclose a pasture for his sheep and his goats. He also wants the sheep and goats to stay separated, so the fencing will need to go down the middle of the pasture as well. Write an equation that represents the area as a function of x, the width of the pasture. So let's draw an x and y axis. Sorry to you, Robbie and Taylor, that I didn't remember to push the marker button before using this marker. You don't know what that means? It's because you're not fit here. Moving on. This has x as the width of the pasture. Personally, I don't know what's the width of the lake, so I like to keep my x being the horizontal. Since x is our horizontal axis, I'm going to make that x. Y then would go in the vertical direction. And so just to label everything, that's how much fencing I would use. So a farmer has 2,500 feet of fencing. So as you can tell, the equation is going to be 2x's plus 3y's, and that would use all 2,500 feet of fencing that he has available. Now, we want to write an equation that represents the area. I haven't even done that. I just told you something about what I was given in the problem. He's got 2,500 feet of fencing, and that's what he wants to enclose. So I haven't even talked about area. As we all know, area equals, in this case, x, our width, and y, our height or length, whichever way you're thinking about that. Now, you notice we have two equations, and at this point, three variables. The easiest way for me to explain what you do next to get down to one equation is to plug the equation that only has two variables into the equation that has one variable. Notice this equation has two variables, whereas our area equation has three unknowns. Both the x, y, and the area are unknown. So what we're going to do is take our equation that only has two unknowns, I'll call it the perimeter equation, and solve it for, and it doesn't matter, x or y. I'm going to solve for y, just because that's what we usually do. So, to solve for y, I'm going to subtract 2x. And then I'll have 3y equals 2,500 minus 2x. Divide by 3. 2,500. 3 doesn't go to 2,500 evenly. I'll write this down here. So we have y equals 2,500 over 3 minus 2/3 x. I don't like to look it out, so I'm going to write it again. Y equals 2,500 2,500 divided by 3 minus 2x over 3. That's what y equals. We only want to write a single equation that represents the area. So I'm going to take the equation I just came up with, what y equals, and plug it in for y in my area equation. So area equals x times 2,500 over 3, erase the arrow, minus 2 over 3x. Let's distribute. Probably don't have to, but let's do it anyway. 2,500 over 3x minus 2 over 3x squared. So, directions for, let's call this part 1, or to write an equation that represents the area as a function of x. And I've done that. So let's box that for part 1. Part 2, state the domain for this equation. State the domain for this equation. When you do your domain, you're looking for the usable part of the equation. As we know, this function is a quadratic function. It's a parabola going downward. Go ahead and pause the video for a second and put it in your calculator. So I have this equation in my calculator. In case you're having trouble, I set my window to -7 to 1,500 on the x-max. And the reason I chose 1,500 is I have 2,500 feet of fencing. I'm not going to use it all in one side, so I knew I was using less than 2,500 feet of fencing. So I just went down to 1,500, which is too large, but that's okay. The maximum is area. So my suggestion to you is always make it a very large number. Because area is multiplication, and that makes the number get large much very quickly. So I have 500,000 for my y maximum. Again, pause the video at any point you need to. So let's go back to our graph. So what is our domain? Well, obviously we want an area of positive. So our domain would be our roots. So go ahead with your calculator and intercept your roots. I'm going to do that by putting y2 is 0 and intersect. I'm just going to do the one on the right because I can tell the one on the left is 0. I have 1,250. So my domain for the width, which is what I'm calling x, would be anything bigger than 0 to anything smaller than 1,250. Notice I used parentheses and not brackets. Reason for this is you actually wouldn't have an area left if you used 0 or 1,250. I'm hoping you realize that I could have just taken each root and set it equal to 0. If x equals 0, x equals 0, I get the lowest of my domain. If I set this equation equal to 0, I will get the higher end of my domain. That's how you would find the roots if you didn't have a calculator. Now, the third part wants us to find the maximum area that can be enclosed by the given amount of fencing. Give a complete explanation of the maximum. So let's go back to our calculator. Clearly, the maximum would be the local maximum, or in this case, the absolute maximum, as well as the vertex. So we're going to go ahead and ask our calculator to do maximum. We're going to get to the left. Hoping you're doing this with me. And get to the right. And we'll enter that. So our maximum area would be the y-up. It looks like 260,416.67 feet. So let's record these two numbers. I'm just going to, we don't need so the area, we're going to put max area. Max area is 260,416.67 feet. So the question is, and the x value would be, what width? What is the magic width that maximizes that area? So the calculator again, 624.999, so we're going to call that 625. 625 feet would be the width. So now I need a complete explanation of how to achieve the maximum. So let's see. I know the width, which is x. Now I need to know y. So let's plug that into our 2500 formula. So we have 2x plus 3y equals 2500. If I know the width, which is x, 625, 2 times 625 plus 3y equals 2500. 625 times 2 is 1,250 plus 3y equals 2,500. So 3y and I subtract equals 1,250 divided by 3. I believe that's going to give you 416.667. So the way to finish this with the nice sentence is, in a pasture is 625 feet wide and 416.667 feet long or height. Then the maximum area is 260,416.67 feet. Nice sentence answer for a word problem. After you understand this, you'll want to try it a few on your homework that look like